Hey there! Let's dive into the intriguing world of information processing, a concept that's super important in today's data-driven era. At its core, information processing is how we take in information, process it, store it, and then use it when needed. Think of it like your brain. It receives data, makes sense of it, stores it, and then pulls it out when it's time to ace that test. Why is information processing important? Well, it helps us make sense of the world. Whether you're figuring out a math problem, decoding a complex text, or even deciding what to have for dinner, you're engaging in information processing. This process supports our learning, decision-making, and problem-solving skills. Plus, understanding these mechanisms can enhance how we design computer systems to mimic human-like processing. So, it's not just about doing well in class, it's about enhancing technology, improving communication, and even boosting productivity in various fields. Key concepts in information processing. Alright, let's break down some key ideas in information processing. First off, we have encoding. This is how information enters the system. Imagine seeing a word on a page, your eyes pick it up, and your brain starts giving it meaning. Next up is storage. Just like a computer, you have to keep that information somewhere. Your brain uses short-term and long-term memory as its storage units. Short-term memory is like a mental sticky note, keeping information handy while you work on it. Long-term memory, however, is more like a filing cabinet, storing data for future use. Then comes retrieval. This is the cool part where you pull out stored information when you need it, like recalling facts during an exam or remembering your best friend's birthday. Finally, we have output. After processing information through the first three stages, you can use this knowledge to act or answer questions. Understanding these concepts helps us learn effectively and can guide improvements in artificial intelligence, making machines smarter and more user-friendly. And there you have it. A snapshot of how information processing works. Whether you're planning to develop technology or just curious about your brain's workings, knowing this stuff is a real game changer. Historical context of information processing. Origins and evolution. Information processing has roots that stretch back further than the first computers. Imagine the ancient societies using beads and counting sticks to manage trade and inventory. These were the first attempts to handle and process information efficiently. Over time, as societies became more complex, the need for better information processing tools grew. With the invention of the printing press in the 15th century, spreading information became easier and faster. This leap helped set the stage for the development of machines designed specifically to process information. Then came the 19th century, a time of significant change. Charles Babbage, often called the father of the computer, designed the analytical engine, a conceptual machine that had many features of modern computers. It's fascinating to see how Babbage's ideas laid the groundwork for what would come next. The early 20th century witnessed the birth of electronic computers, starting with machines like the ENIAC, which helped to transform information processing from a manual task to an automated one. Impact. Over time, the impact of information processing on our world has been profound. Initially, it was mechanical calculation machines that revolutionized mathematics and science. But soon, the growth of electronic computers in the mid-20th century powered a wave of innovation across multiple fields. Imagine how businesses transformed as they could now handle vast amounts of data quickly and reliably. Governments, too, started using computers to manage everything from tax collection to aerospace research. Fast forward to the late 20th and early 21st centuries, the processing of information has become central to everyday life. The rise of the Internet marked a new era, creating a digital world where information could be processed and transmitted globally in seconds. This shift not only enhanced communication but also allowed for the swift exchange of ideas. Today, information processing is at the heart of industries ranging from healthcare to entertainment, shaping how we live, work, and connect with each other. It has made our world more interconnected and opened doors to innovations that were once a dream. Theories of information processing. Information processing is a fascinating topic. Let's break down some of the core theories that help us understand how we think and learn. Cognitive theory. Cognitive theory is all about how we understand and process information mentally. Think of your mind as a computer taking in data. This theory suggests that our brains receive, organize, store, and retrieve information much like a computer does. Imagine you want to learn a new language. Cognitive theory explains how you might file away new vocabulary and rules, helping you access them when needed. It highlights the importance of memory and how different types of memory help us learn and solve problems. Understanding this can help you find better ways to study, like chunking information into small pieces or using mnemonic devices. Behaviorist theory. On the other hand, the behaviorist theory shifts the focus. It doesn't dig deep into what happens inside your mind. Instead, it looks at how the environment around you can shape your learning. This theory suggests that learning is a direct response to stimuli, and it often involves rewards or repeated experiences. For example, if you're learning to play an instrument, practicing regularly and receiving positive feedback can boost your skills. Behaviorists believe that we learn best through a system of rewards and reinforcements, making repetition and feedback key in this approach. So, next time you're learning something new, consider how your surroundings and experiences can aid your education. Constructivist approach. Last but certainly not least is the constructivist approach. This theory takes a different spin, proposing that we build our understanding of the world based on our experiences and interactions. Imagine you're piecing together a puzzle. As you play and explore, you construct knowledge based on what you encounter. This approach emphasizes active learning, where we learn by doing. It's about engaging with your environment, asking questions, and connecting what you learn to real-world situations. Teachers often use this approach to encourage critical thinking and problem-solving, helping students make sense of information in a meaningful way. Each of these theories provides a unique lens for understanding how we learn, helping us discover the best ways to process information. Stages of information processing. Understanding how we process information is pretty cool. Let's break it down into digestible stages. Sensation and perception. First up, we have the sensation and perception stage. This is where it all begins. Sensation refers to our ability to detect stimuli from the environment. It's like when you feel the warmth of the sun on your skin or hear your favorite song on the radio. This is just the raw data being picked up by your senses. Perception, on the other hand, is how you interpret these signals. Think of it as turning those sensory inputs into something meaningful. It's the moment when you recognize that sound as music or the warmth as sunlight. Perception helps us understand and interact with our world by giving context to all the sensory input we receive. Encoding and storage. The next step in our journey is encoding and storage. Once your brain makes sense of the information through perception, it moves to the encoding phase. Encoding is the process of transforming what we perceive into a format that can be stored in our brain. Imagine it like saving a file on your computer. Storage is where this encoded information hangs out until we need it. It's like the memory folder in your brain, keeping everything organized and ready to go. Short-term memory holds onto information for a brief time, like remembering a phone number long enough to write it down. Long-term memory, however, stores information that we might need in the future, such as important dates or the name of your first pet. Retrieval processes. Finally, we reach the retrieval processes. This stage is all about accessing that stored information when you need it. Retrieval is like searching for that saved file on your computer, allowing you to pull up the name of a movie when you're talking with friends or answering a question on a test. Sometimes this process can be smooth, while other times it might feel like your brain is playing hide and seek. Retrieval processes can depend on several factors, like the clarity of encoding, how often you revisit that information, and even your emotional state. With practice and repetition, retrieval becomes more natural, making it easier to access the information stored in our brains. Applications in education enhancing learning experiences. Let's dive into how information processing can spice up learning. Imagine being in a class where lessons are not just about old-school lectures but interactive activities. Information processing helps tailor teaching methods to different learning styles. Visual learners benefit from videos and infographics, while kinesthetic learners get more hands-on activities. It's really about making learning engaging and fun, helping students better grasp and retain new information by appealing to each person's strengths. This approach helps make the connection between what students learn and how they learn it, making the experience richer and more effective. Impact on curriculum design. Next up, let's talk about curriculum design. Information processing shapes how educators plan lessons and courses. By understanding how students absorb and process information, educators can create more effective curricula. This involves incorporating a variety of activities such as group discussions, projects, and multimedia resources that cater to diverse learning preferences. By focusing on components like attention, memory, and reasoning, teachers can build lessons that not only cover the essentials but also encourage critical thinking and problem solving. The goal is to equip students with skills that go beyond the textbook, preparing them for real-world challenges. Role in educational technologies. Finally, educational technologies cannot be ignored. They play a huge role in the classroom, and they're powered by principles of information processing. Think about all those apps and tools that make learning interactive and personalized. From smart boards to learning platforms like Khan Academy, technology uses data to adapt to individual learning needs. For example, if a student struggles with a math problem, educational software can offer additional exercises or suggest video tutorials. This tech-savvy approach ensures that every student navigates their learning path at their own pace, making education more inclusive and accessible. Educational technology thus not only supports traditional teaching but also opens doors to new ways of acquiring knowledge, further enhancing the educational landscape. Information processing in technology. Computational models. Hey there, students! Let's dive into how computers process information. We start with computational models, which are like blueprints for solving problems using algorithms and data structures. These models help us understand how computers think and work. They range from simple ones, like automata that perform basic tasks, to complex ones, like neural networks inspired by the human brain. By learning about these models, you can grasp how computers tackle problems and make decisions. Artificial intelligence and machine learning. Now, let's talk about something super cool: artificial intelligence, AI, and machine learning, ML. You know how in sci-fi movies, computers seem super smart? Well, AI and ML make that possible in real life. AI refers to machines performing tasks that usually require human intelligence, like understanding language or recognizing images. Machine learning is a part of AI where computers learn from data to improve over time, like a robot getting better at playing chess as it plays more games. These technologies are revolutionizing everything from your smartphones to self-driving cars. Data processing techniques. Finally, let's chat about data processing techniques. You might hear, data is the new oil, and it's true, data drives our digital world. So, how do we process all this information? Techniques vary depending on the task, but some common methods include batch processing, handling data in big chunks, and real-time processing, dealing with data as it comes in. Imagine a social media platform where posts need to be displayed instantly. That's where real-time processing shines. By mastering these techniques, you can help make systems faster and more efficient, ensuring all the apps and devices we rely on work smoothly. In summary, understanding information processing in technology lets you peek under the hood of all the cool gadgets and software you use daily. Whether it's through computational models, AI and ML, or data processing techniques, each plays a role in making technology smart and responsive. Keep exploring, and you'll soon be driving the innovations of tomorrow. Challenges in information processing. Cognitive overload. Hey there, ever felt like your brain is just too full? That's cognitive overload in action. It's like trying to watch 5 YouTube videos all at once. Pretty impossible, right? When we take in too much information quickly, our brains can struggle to keep up. Imagine you're diving into a new subject, and you're bombarded with facts, figures, and complex concepts. Your brain might start to short-circuit. To handle this, try breaking information down into smaller chunks. It's easier to process and helps avoid that overwhelmed feeling. Misinformation and bias. Now, let's chat about misinformation and bias, two big challenges when it comes to processing information. Think about when you're searching for the answer to a question online, and boom, you see conflicting answers. It can be tough to know what's true. This muddle of misinformation can happen anywhere, from social media to news outlets. On top of that, there's bias. Bias shapes the way we see information based on our own experiences and beliefs. It means we might pay more attention to things that confirm what we already think, and ignore other facts. To navigate through this, it's important to value sources, check facts, and be open-minded enough to see different perspectives. Technological limitations. Finally, let's talk tech. Technology can be an awesome tool for handling information, but it has its own set of limitations too. Ever experienced a slow internet connection at the worst possible moment? That's one example. Tech can also filter and limit the information we see through algorithms, those bits of code determining what pops up in your feed. Sometimes, it means we miss out on discovering new ideas or viewpoints. To work with, and around, technology's limitations, use a range of tools and sources, and remember, learning isn't just about absorbing information quickly. It's also about stopping to think, reflect, and understand what you're taking in. Keep exploring, asking questions, and seeking answers. Future trends in information processing. Advancements in neural networks. Neural networks are a hot topic in the world of information processing. These artificial systems mimic the way our brains work, allowing computers to learn from data and make predictions or decisions with little human intervention. One exciting development is in deep learning, a subset of machine learning that uses layers of neural networks to process complex data. This technique has already made a huge impact in areas like image and speech recognition. Imagine apps that can tell you what's in a photo or accurately transcribe spoken words. As we develop more sophisticated algorithms and have access to more data, neural networks will only get better. This means they can tackle even more complicated tasks and provide smarter, more intuitive solutions. Quantum computing prospects. Quantum computing might sound like science fiction, but it's slowly becoming a reality. Traditional computers process information in binary bits, zeros and ones. Quantum computers, on the other hand, use qubits, which can represent 0, 1, or both simultaneously, thanks to a weird principle called superposition. This allows quantum computers to handle a massive amount of data and solve complex problems much faster than regular computers. Picture a world where calculations that take years could be done in seconds. While we are still in the early stages of quantum computing, the potential is vast. It offers the promise of breakthroughs in fields like cryptography, materials science, and medicine. Integration with Internet of Things. The Internet of Things, IoT, is all about connecting everyday devices to the Internet, enabling them to send and receive data. We're talking about smart homes, where your fridge tells you when you're low on milk, or a city network that monitors traffic and air quality in real time. As IoT grows, information processing will play a critical role in managing and making sense of the sheer volume of data generated. Future trends suggest a tighter integration where smart devices not only communicate with each other but also use advanced processing techniques to analyze data and act autonomously. This could lead to more responsive, efficient, and intelligent systems that change how we live and work. Comparing human and computer information processing similarities and differences. When we talk about information processing, computers and humans often come to mind. Both process information, but they do it in different ways. Computers handle data using binary code, which is a series of ones and zeros. This might sound technical, but it's just a method for computers to store and interpret information. Humans, on the other hand, process information through our senses and brain. We see, hear, and feel the world, and our brain makes sense of this input. A similarity between the two is their ability to store and recall information. Computers have memory, which can be anything from hard drives to cloud storage. Humans have memory too, both short-term and long-term. We remember facts, experiences, and skills. However, humans can forget things over time, while computers retain data as long as there are no technical issues. Strengths and weaknesses. Understanding the strengths and weaknesses of humans and computers can be eye-opening. Computers are incredibly fast at processing information. If you ask a computer to do a complex math problem or search a massive database, it can do it in seconds. Humans, however, might need considerably more time to tackle such tasks. This speed is a significant strength of computers, and it's why we rely on them for so many operations today. On the other hand, humans excel in creativity and understanding context. We can think outside the box and come up with original ideas. We can grasp new concepts that computers struggle with unless explicitly programmed to do so. For example, telling a computer a joke won't get the same reaction as it would from a person, because understanding humor often involves complex social and cultural knowledge. While computers may be efficient, they can't operate without explicit instructions. Their processing abilities are limited to what they've been programmed to do. Humans, meanwhile, can learn, adapt, and innovate far beyond their immediate programming. This adaptability makes humans unique in processing a broad spectrum of information beyond just raw data. In this way, both humans and computers have their unique roles in the realm of information processing, complementing each other's capabilities. Tools for information processing. Software and applications. Let's dive into the exciting world of software and applications. These nifty tools are essential for processing information. Think about all the times you've used word processors like Microsoft Word or Google Docs. They help us put thoughts into neat, readable formats. Then there's spreadsheet software like Excel. It's perfect for handling numbers, making calculations, or creating charts, which makes data easier to understand. We can't forget about database management systems like MySQL or Access. They store and organize large amounts of information, ready to be retrieved with just a few clicks. For more complex data processing, there are software options like MATLAB or R, especially handy in scientific research and data analysis. There are also applications that assist with creative projects. Programs like Adobe Photoshop or Canva let us design and manipulate images, making our ideas come to life visually. And for communication, tools like Slack or Microsoft Teams keep us connected, allowing information flow in real time, even when we're miles apart. Hardware considerations. Now let's chat about hardware, the physical side of information processing. Your computer or laptop is the first thing that might come to mind. These machines are powerhouses, running the software we talked about. But what's inside them is equally important. The CPU, often called the brain of the computer, processes instructions from programs. The faster and more powerful the CPU, the quicker it can handle tasks. Memory, or RAM, is another crucial part. It temporarily stores data that the CPU uses, so having more RAM means your computer can process more information at once. Don't overlook the importance of storage, either. Hard drives, whether traditional HDDs or quicker SSDs, are where all your documents, applications, and media reside. Peripherals like keyboards, mice, and monitors also play vital roles. They serve as the bridge between us and our machines, allowing us to input information and see the results of our processing efforts. Last but not least, consider network hardware like routers or modems. They ensure smooth data transfer, connecting us to the internet and each other. Role of information processing in decision-making. Decision-making can be tricky, especially when you have a lot of information to consider. Let's dive into how processing this information can influence the decisions we make. Analytical versus intuitive decisions. When making decisions, we often find ourselves bouncing between two styles, analytical and intuitive. Analytical decisions are like that math problem you solve step by step. Here, you gather all the facts, weigh the pros and cons, and then arrive at a conclusion. This kind of decision-making is detailed and logical, relying heavily on processing information in a systematic way. You're like a detective piecing together clues to solve a mystery. On the flip side, intuitive decisions are more like following your gut feeling. These decisions come quickly and don't involve much deliberate analysis. It's almost like your brain is using shortcuts based on past experiences without you even realizing it. For instance, have you ever met someone and instantly had a good or bad feeling about them? That's your intuition at work. Both styles have their time and place. Sometimes, sticking to facts helps, while at other times, trusting your instincts leads the way. Impact on problem-solving. Information processing also plays a big role when we're faced with problems to solve. Imagine you're trying to fix a software bug in your coding assignment. Analytical thinking might have you retracing your steps, looking for where you went wrong in the code. This approach can help break things down into manageable parts, making it easier to pinpoint the issue. However, sometimes analysis just isn't enough. That's where intuition jumps in. This might happen if you suddenly remember a similar problem you solved before, allowing you to fix it quickly without diving into intricate details. Being able to switch between these two methods makes problem solving more effective. Whether you're crunching numbers or going with your gut, understanding how information processing works helps navigate through complex decisions and problems, making life's puzzles just a little easier to solve. Environments, we'll gain deeper insights into effective teaching strategies. This data can help refine educational practices, ensuring that we cater to diverse learning needs. In summary, while the basics of information processing remain crucial today, future developments promise a world where learning is more personalized and effective than ever before. It's an exciting time to be a student, with so many possibilities on the horizon.